Hi guys. In our last session, we have seen about synchronization vertexes. We'll continue the synchronization techniques. So, why do we need synchronization? What is the need of synchronization? To protect critical section. Am I audible? Am I audible?
Yes.
Okay, good. So last session we have seen mutexes. Let's continue the different synchronization techniques. So, what is a reader-writer problem? You have a shared resource, like a global variable. You want it to be accessed by multiple processes. So, suppose you have two kinds of processes. One is the reader, the other is the writer. So, any number of readers can read from the resource simultaneously, but only one can write to the shared resource. So, you have two kind of processes, reader and writer. Multiple readers can read simultaneously, but only one writer can write. But when a writer is writing to the resource, no one should access the resource. Whereas writer cannot write if there are non-zero number of readers accessing the resource. So writer should wait until all the readers are reading the resource. So this is the problem, reader-writer problem. You have a resource, you have two kinds of processes, reader and writer. Any number of readers can read from the resource, but only one writer can write. And when writer is writing, no one should read. When write and writer can only write when there are non-zero number of readers accessing the resource. So how can I accomplish this by using mutex? I have a read function and I use a mutex. I log the resource. I perform my shared resource, accessing the resource. I unlock the resource. In case of write, I lock it, perform the writing operation, and unlock it. So this is okay. This is we don't have any data corruption because here because we are using a mutex and only one will be able to access the shared resource. One thread will be able to access. But the problem here is readers must write while the writer is writing and vice versa. So that is okay. Reader has to wait while the writer is writing. But the problem here, another problem is reader must also wait for other readers. So you can see here, if I have two readers, the second reader has to wait until the first reader completes. Even if the reader is only reading the value, it's not updating the value, all the readers have to wait until one of the readers is completed. So this is the problem with mutexes. One readers must wait for the other readers. So in order to avoid this, we have something known as reader-writer locks. So reader-writer locks are similar to mutexes, but you have higher degree of parallelism. In case of mutex, you have either lock or unlock, and only one thread can lock. Whereas in case of reader writer lock, we have locked in read mode, locked in write mode, and unlocked. So there are three cases. Whereas only one thread at a time can hold a reader writer lock in write mode, but multiple threads can hold a reader writer lock in read mode. So you have lock in read mode. So multiple threads can be locked in a read mode, but only one thread can be locked in a write mode. So when a reader writer is write locked, anyone who's accessing to read it is blocked. When it is a read locked, any thread attempting to read it is given access. But any thread attempting to write it will be blocked until all the threads have released their read locks. So reader writer locks are suited for situations where we have more reading than modification. So the APIs are initialization API, RW lock init. So we have pthread underscore mutex init. In this case, we have pthread underscore mutex. Instead of mutex, we have RW lock. And while destroying, you will be using this. To lock, if you want to read, there is two different APIs for locking. One is while reading, one is while writing. Whereas in case of mutex, you only had one API. But here you have two different APIs. One API is for reading lock, RD lock. The other API is for writing lock. To unlock, we have the same API. So using this, we can have reader writer problem solved. So let's see an example of this. So we start off from our main function. We have two threads. We initialize our reader writer lock. We say null means we don't pass any, we are using default attributes. We create a thread which calls this function. We create another thread which calls this function. So we have one read thread, the other is the write thread. So let's go into the read thread. The read thread, I call reader lock. I call read lock and I read the value of the global resource. I sleep for 10 seconds and I call unlock. Then I increment this for 1. So this is running a while loop for 2 times. In the write lock, I call, instead of, you can see we have now two different APIs here. Here we have RD lock. Here we have write lock. In case of mutex, we have only mutex lock, mutex unlock. We don't have mutex write lock, mutex read lock. So you call write lock and you update the value, and then you call unlock. And also in your main thread, you're also trying to read the value. But whenever you're trying to read, you have to use read lock. Whenever you're trying to write, you have to use write lock. And then finally, you are joining the threads to clean up the resources. So read value of global area. Main also is trying to read. Now both are read. Now when write will perform now. We are having sleep of 10 seconds. Now you have seen write is changed to 5. Now we have read. Now it completes the program. As we are sleeping for 10 seconds, now it is sleeping for 10 seconds. Any queries? Same thing. We have two threads. We have a reader writer lock. We initialize it. We grab a read lock. So we're trying to grab a read lock again. What will happen when we try to grab the same lock? We are saying what will happen. and then we are trying to create a thread, read lock thread, and we are unlocking it. Then we are trying to create a write thread, we are unlocking the second one. Then we are waiting for them, and then we are destroying. So you can see what in this we are trying to call read lock twice. So will this work? Can I call read lock twice? I'm not calling write lock. So multiple threads can call read lock, right? But in the same thread, I'm calling read lock twice. So for that, I'm also calling unlock twice. So only when I call the unlock, second unlock, I can perform write operation. In the write operation, I call write lock, and I don't do anything here. In the read operation, I call read lock. So I have initialized the read write lock. I grab the read lock. Again, I have grabbed it second twice. Now I'm creating a read lock thread. I'm unlocking the first read lock and then creating a write lock thread. So only after all the threads are unlocked, all the read lock threads are unlocked, I got the write lock, perform my operation, I have been unlocked. So any queries in read write locks? So any queries here? Like we have in case of mutex, we have mutex lock, mutex unlock. Whereas in case of read lock, read write, we have pthread, rd lock when you are reading, wr lock when you are writing. And for unlock, we have same. There is only one lock. There is no read unlock and write unlock. It's common for both. So we have seen read write locks. This is a synchronization technique when you have multiple readers and writers. Next synchronization technique is conditional variables, condition variables. So what is a condition variable? The condition variable is a mechanism which allows threads to wait for some event to occur. So there is an event which all the threads need to wait, then you can use condition variables. Several threads may wait on a condition variable until some other thread signals the condition variable. So until a thread signals a condition variable, the other thread will be waiting on the conditional variable. When a thread signals a condition variable, one of the thread will wake up. So you can see not all the threads wake up, one of the thread will wake up. If you want to wake up all the threads, you can use a broadcast method. So by default, this condition variable will not provide locking. You have to use a mutex along with the conditional variable to provide the locking when you are accessing this condition. So condition variable is used when you want to wait, when you want to allow multiple threads to wait until a particular condition is occurred. So how can I create a condition variable? The data type is this, and you can use the macro when you are using statically allocated condition variable. But if you are using dynamic, you can use pthread count 8. And when you are destroying, you can call this. So how can I signal a condition variable? I have to call pthread underscore conditional underscore signal. But if this will only wake up one thread. If I want to wake up multiple threads, I have to call pthread underscore con underscore broadcast. How to wait on a condition variable? I have two functions. Pthread conditional wait and pthread conditional time wait. So if I want, I can use the difference is the second one will return an error value e timed out if the timeout has passed, whereas this will continuously wait until I receive a signal. This will wait for a particular timeout. This will continuously wait. Then destroying is so you can see the sequence is same. You need to destroy, to signal you wait, to either you lock or you unlock. So this is the basic code. I have a pthread. I create a thread and this function, and then I am doing my some job. So I'm just doing some job, some time consuming job here. So it may come here. I have conditional variable statically initialized. I have mutex. I log the mutex here and I call wait. Now I'm waiting for this condition. So this will wait until someone signals it. So once it completes, the main thread completes the operation, it will again try to acquire the mutex. So here you are already acquired the mutex, right? And you are calling conditional wait. So when you call conditional wait, the mutex will be unlocked and you will be in a wait state. And when someone signals, your mutex will be acquired back. So even if you lock the mutex here, when you call conditional wait, the mutex will be unlocked and you will be going to lock. So then the main thread will be able to print the log. It will signal the conditional variable and unlock. Now we'll come here to the signal my main thread. I will perform some operation unlock. So this is a very basic example where we are signaling this waiting this. So you can see it is creating a thread. It went to thread function. Thread function acquired mutex lock and it was waiting for the signal. Then main came and it acquired the mutex lock. It printed the count. It signaled thread. Then it unlocked the mutex. Then the thread function was now you can see the thread function came. It was signaled by the main thread. It also performed the count operation. And it unlocked the mutex. Very simple example, right? So we had a conditional wait here. It was waiting until it called conditional. So in this case, I have the same example I have updated. I have two threads. In the previous example, I had only one thread. I have two threads here. So I create two threads with the same function, and this is the same operation. In the thread function also, I'm just added the parameter r. I'm passing the thread ID 0, thread ID 1. 0 is 1, 1 is 2. So I'm printing the thread number who is working in it. The code is same here, just waiting for the mutex. So the second argument to the conditional wait is mutex. So this, when you pass this mutex, it will be unlocked and the thread will be in the waiting state. And once someone signals it, this mutex will be locked back. So you can see whenever you are using conditional variable, you have to use mutex. So I run this code. So I have created a thread. I went to the thread function, acquired mutex lock, and as I call conditional wait, the lock became unlocked. I went into the thread function too. I call mutex lock. It became unlocked. The main came. It acquired mutex lock. It's signal thread, and now you can see only one of the thread is signaled. The second thread is still waiting for the signal because pthread underscore signal will only signal one of the thread. It will not signal all the threads. So this will now continuously wait, and as the main thread is executed, this is like hand to waiting for signal. So as we are using conditional signal here, this conditional signal will only signal one thread. It will not signal multiple threads. So to broadcast signal, I have to use conditional broadcast. This will broadcast the signal. So now if we have multiple threads, all of them will receive this. So let's try this. So all of them have waiting now. So thread 1 got signaled. You can see thread 2 also got signaled. So main came, main signal the thread. So thread 1 got signaled as well as thread 2 got signaled. Any queries?
Sir, can you open the first one?
Yes.
Main.
Yeah.
Sir, suppose here we locking the mutex,
This one.
then we signal.
Yes, we have to
And
use.
suppose we don't unlock this mutex.
If you don't unlock this mutex, it will not be. This will not be called. So you are not unlocking the mutex. This one, right?
Hmm.
And you're saying whether I will get my signal or not. Correct?
Yes. Yes. Yes.
I will, what happened? See, the signal is not received. Main was called signal thread. I'm still waiting for it. So when you unlock, right? When you call unlock here, it will come here. It will be locked. This mutex will be locked. This is the same mutex, right? This will be locked. Any other queries? So we have seen two synchronization techniques. One is reader writer locks. The other is conditional variables. So why do these conditional variables need a mutex? So the first reason is this will prevent a signal or broadcast function from being lost. So you can see I have two threads. I'm checking the condition and then I'm doing conditional wait. So suppose I'm in this state and CPU has scheduled my thread. I came to the next state where I call signal. When I call signal and I don't have anyone to wait, so that signal is lost. Now I call the CPU has scheduled the thread 1 and when it calls conditional wait, this particular signal is lost. So if you don't have mutexes, then there are chances of broadcast or signal functions from being lost. So hence the reason of we need to have mutexes. So if you have both the threads have locked the mutex, the signal will not be sent until you have conditional wait point, which internally unlocks the mutex. The, the second reason is as we are updating the critical section, shared resource, we need a mutual exclusion. As we are updating the value of answer here, right? As answer is shared between multiple resources, we need mutexes. Otherwise, there may be database. So what happens when I call pthread conditional wait? When you call pthread conditional wait, right, it performs three actions. The second argument is mutex. This is unlocked. And then it waits. It waits until someone calls pthread conditional signal. This is performed atomically. And when someone calls signal, the mutex is locked back. So first it unlocks here, it will lock it back. Thread cancellation. How can I cancel a thread? If I want to cancel the thread, what can I do? Cancellation allows one thread to terminate others. So why do you want to cancel? You may want to save some system resources like CPU time. And you have determined that your thread is no longer necessary. So example can be like you're performing a thread is performing a read-only data search. Like you have multiple threads which are performing this search. And if one of the thread has given you the result, you don't want to use the other threads. You can cancel the other threads because you got what you want. As initially all the threads were performing a data search. Once one of the thread gave you the result, you can cancel all the remaining threads. So how can I cancel it? I have to call pthread underscore cancel. So when you call this function, it needs a thread ID as a parameter. So it will only send a request. It will not cancel the thread. It will send a cancellation request. Whenever the target thread receives a cancellation request, the reaction will depend on two attributes. One is the state, the second is the type. First one is state. You can set the state using set cancel state. So there are two states. One is cancel enable, cancel disable. By default, the cancel is enabled. If you have cancel disable, if someone sends you pthread underscore cancel, the cancel will not work. You should have the cancel enabled for the cancel to work. So you can set the state. The second argument is like if you pass, you want to find out what is the old state, you will be receiving it. Then we have type. First one was state, whether you want to enable the cancellation or disable the cancellation. Then there is type. It is deferred or asynchronous. By default, it is deferred. Deferred means the cancellation is deferred until a thread calls a function that is a cancellation call. So until a thread calls a function which is a cancellation call, the cancellation is deferred. Asynchronous means anytime upon receiving the cancellation request, the thread is cancelled. Whereas deferred is until it calls a cancellation point. What is a cancellation point? So there are some functions which POSIX define, which allows a thread to be cancelled. If I go to man pthreads, search for cancellation functions. So cancellation points. POSIX specifies certain functions may be cancellation points. If a thread is cancelable, its cancelability type is deferred and a cancellation request is pending for the thread, then the thread is cancelled when it calls a function which is a cancellation point. So whenever your cancelability type is deferred and someone has sent you a cancellation request, if you call any of these functions, these functions are known as cancellation points. If you call any of these functions, the thread will be cancelled. If you don't call any of these from this, the thread will still be working. It will not be cancelled. So we have these are the cancellation points. So there is a user specific cancellation point. If you call this, you can also cancel it. So this is the user specific cancellation point. And these are the normal functions which we already use, like open. So to send a cancellation, we have to call pthread cancel. It only sends a cancellation request. The reaction will depend on the values of these two attributes. State is either enable or disable. The default value is enable. Type is deferred or asynchronous. Asynchronous means whenever you receive the cancellation request, the thread is cancelled. Deferred is until your function reaches a cancellation point. And we know what are the cancellation points in the pthread language. We'll see some examples. So the old code which we are doing, same code, I'm calling pthread underscore cancel here. So before doing a signaling, I'm just calling pthread cancel. So the logic is same. I'm not changing it. So when by default, the thread is cancellation enabled and deferred. So there, printf is a function which is executing. The printf is present in. You can see where the printf is present in, or you can see where the write is present. Printf internally uses write. So whenever printf is also a cancellation point. So whenever you are executing printf, or you're going to execute printf and you receive a cancellation request, the thread will be cancelled. You can try this one. So thread is acquired mutex. You can see that even I have signaled the thread got terminated because I have sent a cancellation request and cancellation type was enabled. Cancellation state was asynchronous. So in this function, in this code, I'm creating a thread. I'm calling this function. I'm printing the state of the thread. Cancel state and then cancel type. And we know by default the cancel state is enabled. Cancel type is either default or default. You can see the default states are cancel enabled, cancel type default. Same in the same code. First, I'm printing the default values, and we know the default values are cancel enable, cancel default, and then I'm changing the state. I'm setting it to disable, state to disable, type to asynchronous, and then I'm printing the type and state. So enable, default, then again disable, asynchronous. I'm calling the thread function. I'm calling sleep now. My thread will execute. I'm calling the state as disabled. I'm setting the state as disabled. So if someone sends me a cancellation request, it will not be released. So I'm performing the operations and then I'm executing. So here, after sleep of 1 second, I'm trying to send a cancellation request. By calling pthread cancel. As I have changed my state to disable, it will not work. So I have set my cancellation. So main has sent the cancellation request. So even main has sent the cancellation request. You can see thread function is executing. So when you change the state to disable, someone calls you cancel, it will not work. In this case, I'm not sending anything state and type. So the state is enabled, type is default. But I'm sending a cancellation. And when I'm sending a cancellation, the thread function will be executing this loop. So this means when this is not a cancellation point. Cancellation point is either of these functions, not a function running a for loop. So when I'm running this for loop and someone calls me cancel, thread will not be cancelled until one of the cancellation point is reached. So someone calls printf for this will execute. Cancellation will happen. So in thread function, main has sent a cancellation request. You can see thread does not terminate it, but once it executes printf, as it is a cancellation point, it got terminated, and you can see it did not print this thread request. So any queries in cancellation? So there is one more synchronization technique which is known as barriers. So barriers is used if you want to wait for n threads to reach a certain point before continuing on to the next step. So you have a multi-threaded calculation which has two stages, but you don't want to advance to the next stage until all the threads complete their first stage. In this case, we'll use barrier. This is a synchronization technique. So when a thread reaches a barrier, it will wait until all the other threads have reached the barrier, and then they will all proceed together. So you can think like you're going for a hike with friends. You have reached top of your hill, but you have reached the top of the first hill, but you'll wait for all the friends to reach, and then you will proceed. So this is like a barrier. So thread has a function. You have a function like barrier wait, which implements this. Like you have to call initially you have to call barrier init, and you have to pass how many number of threads which are participating in the barrier. So you have the barrier init. You have to pass the barrier data type attributes by default null. You can change it. And how many threads are actually participating in the barrier. This is for initialization. This is for destroying, and this is for waiting. When you call wait, the thread is put to sleep until the barrier count is satisfied. So if all the threads come and call barrier wait, so this many count of threads should call the barrier wait. Once all of them call wait, then all of the threads are signaled awakened. Until then, all of them are put to sleep. So this is for barriers. See an example. So I have a barrier. I have the variable macro set to 4. I create 4 threads. I initialize my barrier. I set the count to 4 plus 1, 5. So why is 4 plus 1? Because main is also a thread, which is calling barrier. So I'm creating 4 threads here, and main is one more thread, 5. All of them are calling barrier wait. So the main thread, and you can see all of them are calling barrier wait. And all of them will wait until all the threads call barrier wait. Then only all the remaining threads will be awakened. And I'm having a like random sleep here. So you can see all of them are waiting for this. Once all of them have called barrier wait, all of them have awakened and they have executed. So this is the barrier. Barrier means once all of the threads have reached one particular point, then only will awake all the other threads. Let's see one more example, it will make it clear. So I have a 45 in size, array of size 45 members. I have 3 threads. I'm filling the arrays like 1 to 45, 1 to 40. Let's say 45 and 45. I'm filling all the values like a of 0 is 1, a of 1 is 2 till 45. I'm calling barrier init. I'm giving number of threads. I have 3. And I'm having a local variable sum. I'm passing here. I'm calling thread 1, thread 2, thread 3. I'm waiting for each of the threads to complete. I'm calling pthread join. Each of them will calculate sum, and they give me the sum, and I'm adding it to the total sum. And finally, I'm printing the total sum. So here you can see each of them are actually calculating some of the part. Like first 15 by them, 15 to 35 this particular thread, 30 to 45 others. And they call barrier wait. Now this will only awaken when all the other threads call barrier wait. Barrier wait. Once all the threads call barrier wait, then this all will be awakened and they will just return the value of sum here. They're returning the value of sum in the argument. and I'm just adding total sum. So all of them are waiting for the barrier. All of them will assume once, like each of them calculated, and then they have like the total sum. So we have seen barriers, we have seen conditional variables, we have seen reader writer locks. We have also seen how to cancel a thread. So how can I call my own functions, cleanup functions? We have also seen this when we are doing processes, like by using AT_exit, we can register a cleanup function which will be called when the process exits. Like similarly, when the thread is going to exit, you can call a cleanup function. So this cleanup function will be called when the thread exits or whenever it is being cancelled. So we have two functions available. One is called push, pthread underscore cleanup push. This will add a cleanup function to a set of cleanup functions. There is pthread underscore pop, that will remove the last function added with the push. So whenever the thread is terminated by using cancel or somehow, its cleanup functions are called in the reverse order. Like AT_exit, or the functions are called in the reverse order of the registrations. Same cases with pthread cleanup. So the last one which is registered will be called first. So then we have this function. The function prototype is this. Cleanup push, you add a function, and you can also pass an argument to this, which is passed here. And when you're doing after your cleanup push, you have to call pop also, whether you want to execute this or not. If you say 0, it will not execute. If I say 1, it will execute. So if you are calling push, you should also call pop. If you don't call pop, you will get compilation. So simple code, I have a thread, I call the thread function. I'm waiting for this. In the thread function, I call cleanup push, and you can see the prototype returns void, accepts void stop. I'm pushing this function, I'm passing a string, and then I'm popping twice. And see, I'm passing 0 as the argument. So pass 0 means it will not execute. So you can see I have called the start and push complete, and you can see this is executed, but the cleanup functions are not executed because I'm calling 0. So these are important here. In case of processes, we are not having pop. We just call AT_exit. We are not having push and pop, but here you have push and pop. You can see in I've just modified the code. I've said 1 here. So to execute the cleanup functions. Now you can see the second handler is executed first. The first handler is executed next. So you have to call pop with 1 for the to execute. If I don't call pop, then you can see what happens. I try to compile this. You will get an error. So pop, if you remove pop, you will get this kind of errors. So pop is necessary. No errors. What happens when I call a cancel? So I have registered my cleanup functions. I'm performing some time consuming task. In this task, when this task is going on, I call cancel from my main thread. So will the cleanup functions execute? Yes, they will execute the cleanup. So thread is started, it is performing some cleanup functions. And the main thread called cleanup, and you can see the cleanup has executed. You can see this line is not executed. This means the main thread got cancellation request. So any queries? So if you are creating many threads to perform a single task, you may need a function known as initialization function, which we need to open a file or initialize a mutex. Till now, we have seen our main thread performing this thing. Our main thread was performing the initialization, calling mutex init, rwlock init, barrier init, but this is not always feasible. We have a solution for this known as pthread underscore once. So it is like a mutexes and conditional variables, a synchronization tool. So using pthread once, if you have this pthread once in a thread function which is called the multiple threads, only this function will execute once. It will not be executed multiple times. So I will see the example. So you have created a function, you have created a type, pthread once, you have initialized it. So you have like 4 threads, you're creating a 4 threads here, and then you're waiting for those threads. In the thread function, you're calling pthread once, and you're passing the init function address. And this init will only be executed once. No matter which thread comes, only once this will be executed. It will not be executed multiple times. So you can see init function only executed once. Whichever thread comes and execute that line, that thread will be able to initially call that. It will not be able to call twice. So this is pthread once. Any queries? So we have covered most of the threads. The final concept is signals and threads. What happens to signals in case of a multi-threaded process? Like if you have a multi-threaded process and you get a signal, what happens? So in case of thread, each and every thread will have a signal mask. We know what is a signal mask. Signal mask is a set of signals which are blocked and which are unblocked. This contains the signal mask. And we know what is signal disposition. Whether you're ignoring the signal, whether you have the default action, whether you are having a signal handler. So each thread is having its own signal mask, but the signal disposition is shared by all the threads in the process. So individual threads can block signals. They can block signals by as they have their own signal mask. But when a thread is modifying the action, all the threads will share the action. So if someone is changing the signal disposition, it is being received by all the other threads as this is shared. So if one thread chooses to ignore the signal and another thread changes it by restoring to default disposition, it will work. Because ignoring the signal will be lost. So I have a signal handler. Hello. Hello. Right? I'm creating a thread. This thread is doing some time consuming task. And in that time, I'm just sending a sick user to my own process by using the rails. So how many times? So you can see only once the signal handler got executed, even when I have multiple threads. So I created a signal disposition, changing the signal disposition by recreating my own signal handler in the main function. This is also being added to the thread function. So when the signal was executed, it was executing this thread into. So like we have each and every thread has signal mask. So this signal mask will have which are the signals in unblocked state, which are the signals in blocked state. So when you create a thread, whoever is calling pthread underscore create, that particular signal mask is inherited. So your main thread signal mask is being inherited by the thread which is running. So whoever calls pthread underscore create, that particular thread signal mask will be inherited. So you can change the signal mask by using pthread underscore signals. There is no sig proc mask. You cannot use sig proc mask here. You have to use this function pthread underscore signals. So when a asynchronously signal is arrived, what is an asynchronously generated signal? It is control C, control slash, control Q. So whenever this is arrived, only one thread will be handled. Will not be handled by all the threads. So which thread will handle? It depends upon the collection of the per thread signal mask. If all of them threads are having signal unblocked, any one of the thread will be selected by the system. So we know the sig proc mask. So we have in our main thread, I'm adding a sig user. I'm clearing the signal set. To it, I'm adding sig user one and then blocking the signal sig user one block. I'm printing this sig user. I will have the sig user one as block. Then I'm creating a thread. In the thread, I'm checking what all signals are blocked. So when we have seen that whoever is calling pthread create, its particular signal mask will be inherited. As you can see in thread function, you can see sig user one is in the set. As we have block sig user one from the main thread. So it is in the thread, in the set. So this is the same code. I call pthread create, and then I'm waiting for the thread to terminate. In the thread function, I'm printing the signal mask first. So I'm passing null here. Then I'm adding sig int into the blocking list. So I'm calling sig int. So I'm changing this in the thread function. I'm checking whether the signal mask is unique in the thread. So if I change it here, what will happen to the main thread's signal mask? It should not change because we have signal mask separate for each and every thread. Only the signal disposition is shared. Then I'm printing it here. So you can see the thread function got completed. It has sig user one is in the set. Sig int is not in the set. So even if my thread has added sig int 2, so program.log. Let's see the log file. So first we are adding from our main thread, we are adding sig user one. Then in the thread function, but it will print with the sig user one is in the set. Then I'm changing the signal mask in the thread function by adding sig int. Then I'm completing the thread function, and the main thread comes back after calling pthread join. I can see sig int is not in the set. Even I add sig int in the thread, it is not here in the main thread. Only the sig user is here. So by this we can say that signal masks are unique. Each and every thread will have its own signal mask. So I'm blocking the signal mask. Second. So this signal mask I have blocked. I have blocked the signal mask. Second. So this example here, I'm creating multiple threads. So I'm just showing you that multiple threads will have its own signal mask. So if one thread is changing the signal mask, this will not affect the other thread. I think you can run this program to see. So, so here we are registering the signal handler for 6 MB. Then we are creating a thread. We are going to sleep. So we have a function known as pthread kill, which will send a kill signal to a particular thread ID. Like we have kill function where you can send a kill signal to a particular PID. We have pthread kill where I can send a particular signal to the kill. And then I'm waiting for this thread to complete, and I have the seek function. So I have you can see this particular signal got fault. The code is printing the name and age. We're changing the name and age here, and then we're sleeping for 2 seconds. So we have most of our signals, we have used signal. So this, we should not use signal, we have to use sig action, which is the latest one, which has more features. Just to make it very easier to understand, we have used signal. But you should not use signal in your code, you have to use sig action. Sig action is the latest function for handling signals. Signals should not be used. So we have completed our threads. If you have any queries, we have completed threads. We have only like this is our topic. If we have time, we may go here, but we may not have time to cover this all 15th one. We may have like we only complete this 14th. IPC mechanism, so we can communicate between processes. You have any queries?